I just found out that Albert Einstein was a real person. I thought he was a theoretical physicist. I got one more. What type of magazines do cows read? Catalogs. All right. Anyways, today we're going to learn about indirect measurement, and which is an application of similar triangles. Beautiful. Should be good. I think we'll enjoy ourselves today. So let's get started. Now, like a lot of geometry, I need a diagram. So let me draw that diagram first, and then I'll start talking. All right. So what we got here is indirect measurement. What we're going to try to do is we're going to try to calculate the height of something that would be difficult to measure on its own. So what I have here is we got a tree and we've got a person. And this length is the shadow that it's casting, all right? So let me improve my art a little bit and get the shadow in there. Okay, good. So now we've got our shadow. And we're going to create two similar triangles. So let's first give ourselves some points. Now we're going to need to say that these two triangles are similar, and we're going to do that using angle, our favorite theorem there for similarity. So let's find the first angle that we're going to say we know that these two corresponding angles are equal. And that first one is going to be right here, okay? We're going to go boom, boom. So we're going to say that angle E is equal to angle B. All right, so because we just assume the person, not my best person over there, but we assume the person is standing straight up and the tree is standing, or whatever the object is standing straight up. Now, if we look at these distances that we have here, one of the things we realize is that this distance, right, that length of the shadow, that's pretty easy to measure. And the height of a person and the shadow that the person casts are also pretty easy to measure. But the height of the object that you're trying to figure out how tall it is, generally not easy to measure. If it was easy to measure, we wouldn't bother doing all of this. Okay, so let's continue with our calculation. We still don't really have similar triangles yet, right? So what I'm going to do is I'm going to draw the light ray that goes from the top of the tree to the end of the shadow. I'm going to draw that. And I'm even going to draw it orange. For the sun! All right. Dude's drawing it orange. Now here's the deal. Here's the physics of the situation. Light rays that come onto Earth are parallel to each other. These are parallel to each other. Every light ray comes in at the same angle. So they're all affecting our shadows in the exact same way. In fact, if the sun was directly above you, and an airplane flew over the top of you, the shadow of the airplane would be the exact same size of the airplane. A lot of times with shadow, we think like flashlights, where the shadow is like larger than the object, because it's emanating from a point. That's not how light works when it comes from the sun. It comes in parallel. So what that means for us is that because these two lines are parallel, we've got this angle equal to this angle. So let me write that. All right, so we got angle F is equal to angle C because of physics. Well, you should probably do better than that. So I just wrote light rays are parallel. These two lines are parallel. So they're going to hit that angle. It's called an angle of incidence, but they're going to be exactly the same. So there we go. Get this drawn in. Those are two angles. Well, let's just write a similarity statement now. Beautiful. All right, so now that we know they're similar, we're ready to solve. And we're going to have really, two methods I'm going to talk about. Method number one is going to be use scale factor. Method number two is going to be relate the proportion of the height of the object to the shadow. Make sure those ratios are proportional. So let's start with method number 1. Let me clean up the board for a second, and let's solve for the height of this beautiful tree. All right, well, let's go. I cleaned it up a little bit, but this is the tree, that's the person. Keep in mind, this is not even in the arena of being drawn to scale. Okay, it's not even close. I made this much bigger than it would be as well. And then, this number is, if this were 13, it should be out here. So let's just keep that in mind. Let's just follow the diagram, not think of how it's drawn. All right. Let's go here. Let's start method number 1. We're going to use scale factor. Well, actually, never mind. I want to align myself with those odd solutions I'm going to put up here. Method number 1, let's use some proportions. So here we go. What we're going to do is we're going to do a proportion between the heights and let's go with pink, and then the length of the shadow. So the length of the shadow and the height of the object. So we're going to say that H is to 34 in the same proportion. That ratio is proportional to 5 is to 13. So a couple ways we could solve this, but I think right now let's just lean into cross multiplying. So I'm going to multiply the top of one ratio to the bottom of the other, and we get 13. All right, well, this tree is approximately 13 feet tall, so maybe we could have just pulled a tape measure on that one, but you understand this was more about showing you the mathematics there. All right, now the other way we could do it is by using scale factor. So here's how we would do it doing scale factor. We would say to ourselves, hey, let's go here. Let's go 34 divided by 13. See what that equals. It equals approximately 2.6. So it's approximately 2.6. What that means, and now I'll erase the previous method. What that means is if you take 13 and you multiply it by 2.6, you're going to get to 34, about. So if you just do the same with 5, you'll scale it up. So we'll go 5 times 2.6, and that should be the same answer. 5 times 2.6 gives us this 13-foot tree. Beautiful. Beautiful! I held the note a little extra for you there. You're probably like, Miss Mel, I kind of wish you wouldn't have held it that long. Hey, I heard that. Don't you dare insult my singing. All right. So we're there. We're good. 13 feet. Beautiful. And you might even ask yourself, well, Mr. Miller, what if you can't see the whole shadow of the object like the trees in the middle of a forest? Yeah, this don't work. In fact, the largest redwood tree, or the largest tree in general, is a sequoia. And it's in like Humboldt County. We're here in California. And it's 360 feet tall. And how they figured out how tall that tree was is they used a laser, right? So they shine a laser up at it. But then the Guinness Book of World Records was like, hey, we want that tree in the book, but we ain't going to trust that laser. So guess what they did to measure the height? I don't know, Mr. Miller. Did they just climb that damn tree? They did. That's what they did. They climbed the tree, took a tape measure, dropped it down. So there you go. Sometimes you just have to climb the tree. Wow. I feel like that's a very inspirational thing to say. Sometimes you just have to climb the tree. Now, there's one more indirect measurement I want to cover, which is the mirror method. So give me a second to get set up, and let's try this one more time. All right, so this is going to be a method. I'm going to describe it a little bit. So this time when I drew the person, I was real intentional. This is actually the eye height of the person. So this measures to the person's eye height. And what you do, and I've done this, it works pretty good. You take a mirror And you keep stepping back far and farther and farther until the peak of the object you're interested in is actually in that mirror. So, and here's the light ray. There's a light ray that goes from there to the mirror to your eyes. All right? And that forms our two triangles that are geometrically similar. So let's give a reason. First reason is, of course, the assumed perpendicularness of the two objects. So let me write that up here on the board. Okay, and I didn't write the reason because it's the same reason as the previous problem. Okay, let's move on. So here's the next one. We've got these two angles are exactly the same. So this angle here is going to be the same as that angle because of physics. Because it's called the angle of incidence and an angle of reflection. But when light comes in and it hits a mirror, it bounces out at that same exact angle. These two angles are beautifully identical. So let me write that. All right, so we've got, and notice this time I used 3. A lot of times I just use 1 when I think it's just inherently obvious which angle it is. But this time there's a lot going on over here, so I used 3 points to define those angles. All right, so we're good. We've got 2 angles. Therefore, similarity statement time. Triangle DEM is geometrically similar to triangle ABM by angle. So once again, now let's set up the problem. We've got easy to measure, difficult to measure. So let me kind of clean this up a little bit, give us some dimensions to work with, and let's solve this thing. All right, let's do it. All right. Keep in mind, once again, not drawn to scale. This person would be giant. This is not drawn to scale. I have to make this triangle bigger so we can see it better. All right. But either way, let's do our first method, which means let's look at the height of the object to what was the shadow, but now it's the distance to the mirror. So I'll draw that with colors first for us. All right, my black marker's got a little orange in it. It was literally bothering me as I was writing. I'm like, I'm just gonna stick with it. We almost to the end of the video. Not changing markers now, Just gonna have to roll with it. All right, so I wrote the proportion, cross multiplied, got the height of the tree at 312.5 feet. Beautiful, beautiful. So that's method number 1. Which is just set up a proportion of the height of the object to the distance to the mirror, or set up that ratio and set them equal to each other. All right, last one is solving this same thing with scale factor. Well, to do that, let me just do it real quick. You would do here. You would say, what number do you multiply 8 by to get to 500? All right, so division will solve that for us. Let's go grab our calculator and go 500 divided by 8. Oh my gosh, it's a terminating decimal. It's a terminating decimal. Man, I got a lot of nerve to assume I was going to have to round that number. I didn't have to round that number. I ain't got to round it. It's perfectly. Hey, get rid of that point. Hey, that point's not supposed to be there. Who put that point there? Did you do it? Did you do it? The room is empty. Ain't no one's over there. Anyways, we're almost there. Here we go. That just means this, that's times 62.5. So what you do is just scale the height the same way that you scale this particular dimension of the triangle. So you just say that's times 62.5. So we would say that 5 times the scale factor. Beautiful. 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 I'm gonna let you in on a little secret. Number 1, you're beautiful, you're talented. Number 2, this is the last day to spring break. Okay, so I can't help but smile today and I even got on a sweater. I'm hoping I don't need this over spring break. I'm going to the desert, okay? So, anyways, as always, I hope this found you well. You deserve that much. Take care of yourself. Stay hip and be kind to each other. Take care.